So in the previous lecture, we have elaborately talked about exception handling in details, and we have learned all the different aspects of exception handling. So in today's lecture, we are going to cover two main important topics that are available in core Java. That is, one is file handling and another one is multi-threading. So before going into file handling, we must learn or we are going to learn some other basic concepts as well. So the power of Java lies in its reusability, or you can actually reuse everything in Java. So the classes and the methods that we write in Java program can be reused. So we have seen that using method overriding, method inheritance. So they can be reused. Okay, so by extending class and implementing interfaces, so we can actually create interfaces as well, and we can implement those interfaces. So we are going to take a look at this particular topic in today's lecture as well. So this will be the end of your Java session, and it will complete all the aspects, mostly all the aspects of core Java section. So what is beyond this reusability? So what is beyond this user-defined class and methods reusability or extending them using extend keyword or inheritance? There are different ways to actually use the inbuilt classes and methods that are available in Java. So we can actually reuse them and remodify them and recreate them by ourselves. How? With the concept of packages. With the concepts of packages. So what is a package? So it is basically a collection of classes or interfaces. So it is basically a collection of classes or interfaces, and we pack them together. That's why they are called packages. So a package is a group of variety of classes or interfaces taken together. So if you combine one or more classes together, you can actually create a package. So let's just take a look at the Java packages that are available inside the library or inside the Java library, like RMI package, AWT package, util package. So you have used this util package to have access to the scanner class. Yeah, so to have access to the scanner class, we have actually used this util class. Similarly, vector was there that was available from this util class. Java.lang. So this is the default library. Default library that is accessible to all the programs that you are going to run. So by default, the library that is inherited, or the package that is imported to any Java program is actually java.lang. So the full form is java.lang. So if you ask the question which is the default library that is always available to your program, that is called java.lang. Then you have java.io, where you have some operations or some classes that are related to input-output operations. Then you have this SQL package where you will find some commands or some classes that can actually use to able or use to enlight DBMS, or you can actually use the database software or database queries within your Java program. AWT is used for user-defined graphical user programs or something like this. RMI is used for remote resource access. Net is again used to define internet applications. Applet is also one of the internet applications that is used. Security package is also there that provides some security measures or some security classes to your program. Then we have text and many more. so many more classes are available, no, so many more packages are available inside the Java library, and it is still in growing phase. That means the packages are still growing. The classes or user defined classes are still growing. So these packages can be like tree structure, like within a package there can be another packages, like in the java.lang package you will find some packages like java.lang.thread, java.lang.math, java.lang.string. So when you import the parent package, these packages are already being imported to your program. So that's why thread, math and string, they are all imported to your program. But to use them, we must either use their objects. So these are the classes, thread, math and string. So you must use the objects, or if this particular classes have some static member, then you can use class name to access them. So lang package has these classes basically, and you can find more on your books. So let's segregate how we are actually using, or how this package is being organized in Java library. Yes, but শুধুমাত্র তারাই পাবে যারা ক্লাস করবে। বুঝেছি, কিন্তু যারা ক্লাস করেছে তারা অলরেডি পেয়ে গেছে ভিডিও। Okay, so Java is the base package of any package you define in your program. So Java is the base package, and this dots actually denotes the paths. That means from which package we are going to which package, and from that package we are going to which class, and from which class we are going to get which method. So this dot are actually member access operators. So lang class is a member of, lang package is a member of Java package, or the base package of Java. Then this math class is a member of this package, lang package. So that's why we have used dot operator. And this sqrt function is a member of math class. So that can also be accessed through dot operator. So we access the hierarchy of packages along with classes and methods using dot operator only. You can see it as a path as well. That means they are actually the paths that you must follow to reach to this sqrt function. So here in this particular example, we have used java.lang.math package. So we have used this java.lang.math package, java.lang.math package, or directly we have mentioned which class we want to use. You have seen this particular examples, like where we have import java dot util dot scanner and import java dot util dot say star. So the difference between both of them you already know, and that if you use this import java.util, so all the classes that are available in this util package is going to be available for your program, whereas if you use that specific class name, only that particular class will be available. But in this particular example, this is basically defining or importing that package is useless, because by default we already have java.lang actually available in your program. So what we have here, we have the value of pi that we have stored in a double value, so 3.1415926.535, And we have used a square root function on that particular value and then try to print that particular value. So math provides us with a lot of methods like math.pow, uh, math.cell, math.floor, math.rnt, math.round. So many methods are there, and you have to use them like this. Why? Because all these functions that are available from math library or math class, as you can see, all are static members. So all of them are static members. That's why you have to mention the class name, and then you have to use that particular uh, function of that class. So we must know that we must include the appropriate package from where we are going to use the class or methods. So we must include that appropriate package. If you want the scanner class to be used, you must include that particular package util in your program. So the import keyword is used to import the libraries or import the packages to your program. So some of the packages I have already mentioned the different working of this packages. So now how we can actually create our own package. So we are not going to check any examples or example like practical example for this because we don't have any time, but they are also interesting. We can create our own package. What we have to do, we have to just instead of import you have to mention package and the package name. So instead of import statement, the package statement will be the first statement in your program. Then you can import any package. So then you can say import java.util.star or util.star. So what will happen? This package name or whatever package name you are giving to your package will already have will by default will have this java.util.star incorporated within that particular package. So the first statement while creating a package in your program or in your file should be the package keyword followed by your package name. So this will create a package. And one of the classes inside your package must be a public class, else that cannot be accessed by any other package. So within your package, one class should be public. So here this particular my class is public. That means this particular class can be accessed from different packages or different programs. Here it is another class. This doesn't do anything. So this is class, and so this particular package, my package, contains two classes. One of them is actually accessible and another one is not accessible. So you can have as many number of as public classes, but at least one class should be public class in your package. So this is a java.file. So what are the points we have to remember while using or while creating our own package? So the package declaration should be the first line in your source code. So that is what I mentioned. So before the import statement, you have to specify the package statement. There should be one and only, So there should be one and only public class. So I was wrong there. So you should have only one public class. You cannot have more than one public class in your package. And that class name should be the file name with the .java extension. So the public class will be the file name of that particular Java file. That means you have to store your Java file with that particular class name. So in this particular example, the file name of this particular class will be my class.java, and you have to compile it. And mind it, uh, this particular class or this particular both of these classes doesn't have main method. In this particular package you don't have any main method. That means what you can do, you can just compile it and leave it like this. It will become a package for your programs. Now you can actually create another class or another file create another file create another file, and on that particular file you can actually import java.mypackage. If you have stored it inside the suppose main library of Java, and if you don't have used or saved this particular file inside your library, or you have that particular file inside the same folder where we have this new file and this particular file, so you can just mention the package name. So this is how you can actually create. So there are some other ways or there are some other things you need to follow. You must create a folder name with that particular package, and in that particular folder you have to mention the class name. So you have to follow those kind of things to actually have access to these packages. So that is what I am trying to say. Create a subdirectory under the main directory and put the .java file there. So that subdirectory name will be the package name. Compile it and keep the file there. So in that subdirectory, you have to again, after compilation, you have to actually move the class file or the class file that is generated from this Java file to this subdirectory. That means outside that particular class or outside that particular folder. So in that subdirectory, you have to mention. So if you do this in practically without using any IDEs, so that will be helpful. But we are not going to do that, because we don't have much time and we have to complete everything. Yeah, so if you want your class or that public class to be inherited, you just use import mypackage.myClass, and you can create an object of your myClass. So as you can see, we have not defined a class named myClass. We are just using the myClass from myPackage. But this is not simple, as you can look or you are looking in this particular section. If you are using any IDE, then it will be by default managed by the IDE. But if you are running it using the console, it will be very hard for the first time if you are running any package program. So you have to create a package. You have to create a subfolder with the name of that particular package, and inside that you will have to keep your class file. So this is how these things are going to work. But if you are using any IDE, both of those, just create two files and your program will run as smoothly. Okay, you don't have to think about anything. If you are using any IDE like say NetBeans or suppose Eclipse, if you are using those IDEs, you don't have to uh, think about the directories where they are being stored. Your program will run very efficiently. So all the classes are unique to package but not to other package. That means you can have the class or in a single package. So suppose this is package 1 and this is package 2. In package 1 you cannot have class R1 and class R1. Here you can have class R1. So this is valid because R1 and R1 are on different packages, but this is not valid. But this is not valid. You cannot have the same class inside the same package. That means classes are unique to package but not to other packages. package name conventionally starts with a lowercase letter. So generally you might have seen that java dot util dot scanner. So from this naming convention, you can actually understand that these two are the packages, whereas this is the class name. So generally class name starts with a capital letter. On the other hand, package names generally by convention starts with small letter. So that I said that class name starts with a capital letter. So now just let us see what are the different type of accessibility that are given to different Java classes. And one more thing I want to rectify, that uh, I said that public, in between public and protected, friendly actually is there, or default specifier is actually there, but that is not true. Default is much more restricted, or much more restriction than protected. So basically, what will be the organization? So private is the most restricted one, then friendly, and then you have protected, and then you have public. So in the second lecture, I guess I have mentioned that friendly is or friendly or default is in between this protected and public, but that is not true. Friendly or default is much more secure than protected actually. Okay, so let us find out what is going to happen here. 1 second. Next second. Wow. প্যাকেজের নামটা মেনশন করে দিতে হবে। তখন লিখতে হবে প্যাকেজ 1.r1, এইভাবে ইউজ করতে হবে, আর প্যাকেজ 2.r, মানে জেনারেলি আমি যদি অ্যাক্সেস স্পেসিফাই এই প্যাকেজগুলো ইম্পোর্ট না করি জেনারেলি, তাহলে আমরা এরকম লিখতে পারি জাভা ডট ল্যাং, নট ল্যাং, সেই স্ক্যানার ক্লাস যদি ডিফাইন করতে হয় তাহলে আমরা লিখতে পারি জাভা ডট util dot scanner sc is equal to java dot util dot scanner system. This is again valid. আমরা এইভাবে লিখতে পারি, but generally we don't actually have any package or any repetitive class in some packages that are provided by Java, but you can actually use this kind of statement as well. So if you import package 1 and package 2 both, you just have to mention package 1 r1, package 2 r1. Simple to distinguish between them. There is no other way. Okay, so let's find out what are the different type of access specifiers that are available in Java, and what they do, or what are their jobs in terms of security that is provided by the Java or by the class. So let's find out what will happen. So there are 5 type of access specifier actually. So public, protected, private, and in between protected and private we have two specifiers. One is friendly, that is by default always given to any class, and there is another called private protected. So let's find out what are the different properties this particular access specifier has. So if you have some members of a class that are defined in the same class, or that are trying to access public protected friendly private protected and private members, and that particular thing try to access from that particular same class, that means some member of same class. So some member of same class, if try to access private protected friendly default, or say private protected or private members, they can actually access it. So everyone within the class have access to all the members. If you have class, say ABC, and you have some public members, you have some protected member, you have some friendly, or so if you have int A suppose here, int B suppose here, so it cannot be like this, protected int C, private protected suppose D, and private suppose E. Suppose you have these four variables, and suppose there is a function, say access all. So this particular access all function have access to everything. That means if it is public member, if it is protected member, if it is friendly member, or default specifier or default member, if it is a private protected member or a private member, doesn't matter. Someone or something from inside the class can actually access everything. Now, what will happen if some subclass is in the same package? So a subclass in the same package, that means you have, say, package, my package, you have a class here, suppose class ABC, and you have class XYZ extending ABC. Okay, so you have class XYZ extending ABCD. Now, from this particular class, from this particular portion, so subclass in same package means this particular portion is being referred. So in from this particular code, what you can access? You can access the public members, you can access the protected members, you can access the friendly members, you can access the private members. Sorry, private protected members, but you cannot access private members. So if something is private here in this particular scenario or in this particular class, only that private members are not accessible by a package, by a class within the same package, or by a subclass within the same package. So from this particular code or this particular section, only the private members are not accessible. Everything else are accessible. Now, other class in the same package. Other class in the same package in the sense you don't have this extend keyword. That means you are not actually extending that particular class. You are just having same class or two different classes in the same package, my package. So from this particular code, you are not going to have access to private protected members as well. So you have two restrictions now. One is private members are restricted. Another one is private protected members are also restricted. What will happen if a subclass in other package? So suppose you have here package MP, and you have a class, say PQR extends ABC. So from this particular code or this particular section, you will have access to the public members of this ABC class. You will have access to the protected member of this ABC class, because we know that protected means all the accessibility goes to the extended class. So protected members are also accessible. Similarly, friendly members are, oh, sorry, I was here, right? Subclass in other package. So public, protected, then friendly. So they are not available. So that is what I said, that some from some other package you cannot actually access this particular classes. So all these classes are not accessible. Similarly, private and protected. So protected, because of this protected specifier, you can actually access this particular uh, or members of this particular class. So private protected members of this particular class are accessible from this particular class. And if you have a private member, so that is not accessible at any way. So you cannot access this private members. And if you have a non-subclass in other package, that means you don't have this. So if you have a package here, you have my package here, you have MP here, that is also a package, and from this particular class you want to access the members of this particular class. So if you create an object of that particular class, if you create an object of ABC class, ABC A1 suppose, you can only have access to the public members. You cannot access anything beyond that. So protected member, friendly member, private, protected, private, nothing can be accessible from this particular class. So these are the 5 level of security known as access specifiers that are available in Java classes. And this particular table is actually summarizing them very efficiently. And one more thing, that whenever we don't mention a subclass, that means we are mentioning that we have to create an object. So other class and non-subclass. This is subclass, this is subclass. So for this two type of classes, that means you have to create an object, and using that object you can actually use, or you can actually have access to these members. And from the subclasses, you can directly have access to them. You don't need an object. So that is the basic principle of inheritance and object-oriented programming. Now let's start with file programming. So suppose you have your input units. So input units means mouse, keyboard, primary storage, secondary storage, network. So Java considers all of them equally. And you have output units like console, printer, primary storage, secondary storage, network. Java also consider them equally, and they are all treated as files. Okay, now this is our program, that is the Java program. So how we can take inputs is basically depends on or basically relies on streams. So to taking inputs from these input devices, you have to go through input stream, and to print something from your Java program or give some output from your Java program, you have to use this output streams. So these inputs streams are actually working as a buffer in between your program and your input output devices. So let us see what are the stream classes available in Java program. So Java streams are divided into two types. One is byte stream, that means the data is taken from the input as a byte stream. That means a byte array, and another way is to use as a character stream or character array. So similarly, both of them also have input stream classes, output stream classes, and input stream classes, output stream classes. So file is one of this byte stream data, or generally for input and output stream, we actually use file memory pipe. In this particular scenario also, we can actually use file memory pipe. So what we can do, we can either use any byte stream or any character stream, and depending on that, you might choose different classes that are available in Java. So there are, again, I am saying, for input output, like you have seen so many classes, all those things, all those input output mechanisms can also be applied for file input output system, because everything is treated as a file in Java. That means you can actually use scanner class to take input into your uh, into your program, but we are not going to use them because some dedicated file handling mechanisms are also available in Java, and we are going to use them. So uh, let's first define or directly define a file object. So to define a file object, you can actually use file input stream. So there are different ways. So file input stream is one of the ways to define file object. So using file input stream, what you can write, so that you can just have to specify the file name. And if your file is stored in some other location rather than the same location of this particular Java file, you just have to mention the absolute path of that particular location. So generally we use try catch block, or you have to use throws IO exception. So we have already learned what is the difference between throws, and when to use throw, when to use throws, when we can actually catch them using catch blocks. We have all covered in our previous class. So we are not going to waste our time here. So what we have done here, we have this particular statement that might have some IO exception. That's why we have used try catch block. Alternatively, you can use this. And this is how, using the files input stream constructor, you can actually create a file object. So this FIS can be used to take inputs as well as, so this time it will only be used to take inputs from the file, because we have used file input stream. We have another stream called file output stream. So that particular stream or that particular file object is going to write something on your file. We are going to look everything into that, and we are mainly we are going to explore 2 or 3 classes that are related to file class, and I am going to show you a live program as well. So this is how you are actually creating an file object, and you can actually alternatively combine this and these 2 statements. So like this, file input stream FIS is equal to new files input stream input.txt. But what will be the consequence of that if you are using them within the try catch blocks is known to you, because if you define this particular file object within this try block, it will be only accessible within this try block. You cannot access this particular file afterwards, after the file try block. So we generally do this kind of activities, like we define the file object here, and then we actually initialize the file object inside the try block, because where the error might occur. Now, there is another way to actually indirectly create file objects using the file class. Okay, so what it does, so file class actually nothing like opening or closing or anything. You just specifying a file here. That means you are just declaring and allocating a path to your file using the file class. You will not have any file not found exception or anything. You will not encounter any kind of exception in file class. Yeah, you can actually encounter an exception called null pointer expression. That means if your file doesn't point to anything or doesn't point to any location, it will give you a null pointer exception. So that is different thing. But it is not tested. That means it has nothing to do with your memory. So it will not search in your memory that whether this input.txt is available or not, whether it can be used or not. It will not check anything. So file is just to tell your compiler that this particular path contains a file, or this is a path, file path, nothing else. So it is to declare that this is a file. And now how we can use this using or with along with the file input stream. So what we have to write, you have to just create a reference of file input stream and just pass that particular file. So here in the previous example, we have directly passed the file name or the path of that particular file. Now we have stored our file path within a file object, and we have passed that file path into our program. So this is how you can actually declare a file or create a file object. Now is used to take inputs from the file that we are going to learn next. But before that, let's find out how we can actually write something using our file output stream. So this time you have to create file output stream object. So for input, we have used file input stream, and for output, we have to use file output stream. So two different classes are being used for input and output in this particular example. So what we are going to do, FOS is equal to new file output stream output.txt. Now here you might generate a exception called file not found exception. Sorry, here we will not generate that file not found exception, because if this output.txt is not available, it will generally going to create this particular text file or this particular file. So you are not going to get any error. We are only going to get an error, that is IO exception. So you know how to resolve that. Now we have defined an integer I don't know why this is defined. I don't think this is required. So what you are just writing, you are taking a byte string, so a byte array, so byte players, where we have some bytes or some characters that are stored, and you just write them using the write command. So fos.write is used to write something on the string. And I am not focusing on this particular string classes because they are rigorous and you have to remember two classes, one for input, another for output. So I am not actually these are not very efficient. These classes are not very efficient. We have one efficient class known as Random AccessFile. We are going to actually focus on that. So Random AccessFile. So we are going to focus on that. So how you can actually handle different type of data. So for that you have to use data output stream. So along with file output stream, so that can only handle bytes, you have to use data output stream that can handle different type of data. Now what you have to do, you have defined a file object. So we have thrown and file output stream FO is equal to new file output stream. So we have defined the file output stream. And now that particular stream must be sent to data output stream. So there is another class. And this data output stream is only able to handle primitive data. So now from using DOS, you can actually write integer, you can actually write double, you can actually write character. And also you must not forget to close all the strings. So we have to close DOS. So we have to close DOS first, because DOS is actually accessing FOS. We cannot actually close FOS then DOS. You have to maintain the hierarchy. So first of all you have to close DOS, then you have to close FOS. So this is how using this write int, write double, write char methods, you can actually write something or write some data on your machine, or sorry, on your files. Then you have another class called FileWriter class. So this is another way to write something on your on some file. So suppose we have this output.txt again, and you want to write something. So what you are trying to do, you are trying to just access or create a FileWriter object FW using the constructor of FileWriter class. Now here, what we have done, okay, so we have taken some inputs through command line. So we have taken some inputs through command line, like string args, and that arguments are being or written in the file using this file writer or write function basically. So here you have to specify the characters that you want to print. So every character is being printed using the file writer or sorry, file writer classes write function. So using the write function, you can print single character in your files. Then how we can read? So how we can actually read something using file input stream. So we have created the file input stream in at first, that means the file object. So now we are going to use that to read something or read some characters and then print those characters on the screen. So what you can do, you can just check for fis.read. It will return -1 if it reaches the end of file. So it will return -1 if it reaches the end of file. So in this particular way, you can actually use or read something from the user, sorry, from the file using the read command, and we are just printing them on the console. That means everything will be written or read from this particular file, and you are just printing everything using your system.out.print. That means you are all printing everything on the console. And don't forget to close that particular file stream. So generally we have read and write method for every classes. Okay, every classes that are available for read and write something from your file. Now, how we can actually read primitive data types? So again, you have to use data input stream. So there was data output stream to handling primitive data type. Now you have data input stream. Now the restriction of using data input stream and data output stream is that you must have a file that is written programmatically. That means using data output stream. If you write something using data output stream, then only you can read that using data input stream. So the file content must be written programmatically. Only then you can actually use this method. So dis.readCat, dis.readIn, dis.readFloat, all these methods are available in data input stream class. Then you also have a file writer that reads one character from your code or from your file and just prints them, or using this read method, it reads one character, maybe the ASCII value of that particular character, and print that. Okay, so you can use file reader class, and from that file reader class, you can use this read method. We are seriously interested in this particular class. So this is called Random AccessFile class. Using the Random AccessFile class, we can write and read. So both operations can be done simultaneously on the files. So what you can do, you can just have to create objects of random access file. Either you have to open that in write mode, or you have to open that in read mode. Read write mode, or sorry, read mode and read write mode. So two modes are available. One is R. So mind that this is not character, this is a string, and this is also a string. Unlike C, where you have to pass R in a single code, that means as a character, here we don't pass them as a character, we actually pass them as strings. So the syntax is simple. Just specify the file either using the string or using a file object. It depends upon you. So here we have used the string, that means to mention the file name. So we have this particular file to, or this particular file object. So it can read the input file, and this particular object, it is used to write something on this output.txt file. So RW stands for read write. So it will be open for read and write, and R, it stands for only read. So there are two more variations as well. R RWS and RWD, I guess, but both of them doesn't serve so many purposes for us, so I'm not going to discuss them. So we only require these two, R and RW. So what are the methods that you can use to write something and read from file? So you can use read int, write int method. So what we have done here, we have read some integer value from this input.txt file, and we have written that particular integer value in this particular output.txt. So that is what happening in this particular code, and this is very efficient. That means you don't have to use two different classes, one for input, another for output. You just have to remember one class, random access file class, and all the methods that are available in random access file class. Also, this random access file actually provides us so many methods like read boolean, write boolean, alternate, read char, write char, read byte, write byte, read float, write float, read double, write double. So they are very easy to remember. So this particular class and the functions that are available in this particular class are very easy to remember. Read line, write line. So it will read one single line. It will write one single line to the file. So these methods are available in random access file. So what are the different controls that are available in random access file? So it gives us a flexibility to actually move the pointer backward and forward. So seek is the method to use the pointer, reading pointer or writing pointer to some other location. So seek 0 means it will move to the first location, and seek 5, suppose, so it will move uh, the pointer to the fifth location. So seek will always works from starting position. That means if you put seek 10, it will move to the 10th byte from the starting location. So seek method is also very useful in this manner. Now we are going to take a look into a live example, and this particular program uh, is used to copy some content used to So this particular program is used to copy the content of one file to another file. And here is some glimpse of thread as well. In this particular program, I have used some glimpse of thread as well, so that it will be useful for you guys, or you can understand what is happening. Uh, so we have a file. So I am deleting this output file. Okay. So first of all, I am deleting this output file. So as you can see, there is no output file. We have this input.txt file where I have written my name is Raymond. Now just let us add some more text. So this is a file copy example. So we have added some text again, and we are just setting it. So as you can see, we have written my name is Raymond. This is a file copy example. So first of all, let's run and check what is happening. Then we are going to explore more about this particular program. So as you can see, the file name is filecopy.java. So Java file copy, sorry, yeah. So Java filecopy.java, that is the file name that we are going to compile. So it is compiled. Now we are going to run this particular code. Now here we have used a command line argument. So that's why I am passing the name of the file that is being as a input to the program. So Java file name. So generally what we do, we just specify the class name. So Java class name, that is file copy. Now in this particular example or in this particular program, we have done so many things. So one of the feature of this particular program is that it provides or it accepts command line arguments. So we have to mention input.txt as the input to your program. And again, clearly see that, that we don't have, so I'm refreshing it, we don't have any output.txt file here. Okay, so if you just enter it, as you can see, copy from input file to output file has started, and it is showing as a progress bar, and it is shown that completed. That means the file copy is completed. Now we can actually check for this input, and now you can see that there is an output folder, output file as well, where if you just open it, you will see that my name is Jiman. This is a file copy example. So our program executed successfully. So that means this particular program has done what is intended to do. So let's find out how we are going to do everything. So we have this import statements. So we have imported java.io.random access file. So whenever you are going to use random access file, you must import that. So I am not using java.io.star. If I am using that, then we don't have to specify random. We don't have to specify IO exception. We don't have to specify file. I don't think random java.random is actually required. Yeah, I have copied this particular headers from another program, so I don't think this is required. So just let it be. Then we have scanner to take inputs, and we have file not found exception. And we also actually require IO exception. This, okay, no problem. So we have IO exception and we have interrupted exception. So I will mention what is interrupted exception later. So we have this headers. Now the class name is the class name is file copy, and we have this main function public static void main string args. We are using this args to take command line input. So what we have defined here, we have defined a file called infile. So this is a file object, not a file instance, or not a file buffer, or not a stream. It is just a file. So infile is equal to null. So initially it is null. What we are trying to do, we are trying infile is equal to new file args 0. Now what kind of error may happen if you don't provide any command line argument? What kind of error will be generated? So we have learned this in previous class, as index out of bound exception will be generated, because array will not have that particular value in index 0 position. So index out of bound error will be generated, and for that particular matter we are going to mention that input file not found, please specify the file name. So what we are asking to the user, that input file name was not found where it intended to be. That means inside that command line we have not found the input file, so please mention the input file. So what we are doing, scanner sc is equal to new scanner system.in. We are using this scanner class to take inputs from the user at that particular time. So our program is not stopping at that particular position. We are continuing. We are recovering from our error. That is exception handling. So in file is equal to new file sc dot new line. So in this particular section, we are actually reassigning the in file so that we can use it for later purpose. So let's find out what is happening if you just execute this particular code. Again, I am rewriting without changing the input.txt. That is, error or exception will generate in this particular section, that is called index out of bound exception. So let's try what will happen, or what has happened. So as you can see, Java file copy, when I run this particular code without the input text, it is saying input file not found. Please specify the file name. So this time I am going to specify the file name. That is input.txt. And now as you can see, copy from the file to output file has started. You can see the progress bar and it is completed. So this is how our program behaves for this particular scenario. That means we have successfully, so this program will be a very good example for everything that you have learned so far. So this is how you are tackling exception that has generated at the runtime with some code inside the catch block. Now we have defined uh, two streams. So one for input, so INF, another one for output. That means input, it will take input from file. That means it will take input from the input file, and output F, it will give, or it will produce an output file with the name output.txt. And we are going to use this particular file as a storage or as a destination for the content of this input file. So we have defined two streams. Now what we are trying to connect the input file with the random access file. Now what might happen that this, as I said that in this file object will not check whether that particular file is actually present in the directory or not, but the stream is actually does that. So random access file will actually check for whether that particular file has been found or not. So that's why what we are trying to create an instance of আছে লেখা আছে দেখাচ্ছি ওটা এখানে লেখা আছে দেখা গেল এই যে ওটা আসছি পরে আসছি সো we have created a random access file and we have passed input file name or input file object. Now, if that particular object is valid, it will not produce any error. If that particular file is not valid, it will produce an error called file not found exception. And for that exception, what we have written, that input file not found, you have crossed maximum tries. That means we have given that particular user a chance twice to give the file name. If that particular user has not given the file name correctly at that second attempt as well, we are just going to exit from our program. So let's find out what will happen if you execute a code up to this particular point. So this time I am not giving any file name. So it asking me for file name. I am giving input without extension. That is wrong. That means input.txt is the file name, but I am giving input. So as you can see, so you will see that the output is, so please specify the file name. So I have given the file name, that is input. So no file name with the input found in the memory or in that particular directory. So what is the message? That message is input file not found. You have crossed maximum tries, exiting. So the program exits from that particular point. So this time we are not going to recover anything. We are not going to ask anything. We are just exiting from the program. Now, if everything is fine, we are not exiting from the program. That means this particular line or this particular code has executed successfully, and we have successfully connected our input file with our INF object. That means the file stream object. Now it will be output. So now let's create let's actually connect the output file. So we have this output.txt file that will be created if it is not already created, and if it is already created, it will be overridden by this random access file. So output F is the object or the file stream that is going to manipulate output.txt, and we have opened this particular file using RW mode, that means read write mode. Now this particular output stream, so but as this is not input, that means we are not reading anything. So what might happen? It may not generate file not found exception, but that is not true. If that particular folder doesn't have the permission for this particular code to create some file, then the file cannot be created. So if some for some unknown reason file cannot be created on that particular location, at that particular time file not found exception will be generated. And for that, what we are doing, we are just writing output file cannot be created, and we are exiting from the code, as well as we are closing all the objects, all the file objects at that manner, and we are returning from that particular program. And I cannot show this particular example or this particular part of execution because that is not possible. So it depends on if the memory size of your hard drive is so high, so full, that one single 1 KB file is not able to create it on that particular folder, or if you change the permission of your folder, that nobody can actually create anything by their own, only they can use it, then in those certain situations you might have this file not found exception. So I am not able to show you how this particular section is going to execute. I hope you have understand what is happening here. Now, let's just try to copy the content of INF to out. So until this particular point, we have already understand that everything is connected. That means we have the input file connected to the input stream. We have the output file connected to the output stream in read-write mode, and the input file is in read mode. Now what we are trying to do, so we are seeking the input file or input file pointer to the starting of that particular file. So we are seeking the pointer to the first for safety, not everything, not is it is not mandatory, but for safety we have just shifted the pointer to the beginning, and we have an integer variable I that is going to use to read some characters, or rather some byte from the file, and we are going to write that particular byte to our output string. So system.out.println copy from input file to output file has started. That was shown here. Copy from input file to output file has started. So what we are doing here, we have a while object, while block. Inside that block, we are reading one item. So I is equal to inf.read. So using the read function, we are actually reading one item. Now to check what is happening inside the read, you can actually read the content here. So as you can see, read a byte of data from the file. The byte is written as an integer in the range of 0 to 255. That means one character is being written, read one at a time. And that particular thing we are writing using the write function. So this write function, what it does, it writes one byte. So one byte will be read and one byte will be written. Now for read we have used inf, and for write we have used outf, because this file pointers are actually being used. One for so outf is for output, or for that output.txt, and inf is for input.txt. So this particular code is used to write that particular file. Now if I just remove this part, oh okay, sorry, I forgot to mention. So I will read some content. So this byte is so what is the range of this particular byte? As you can see, the range is 0 to 228. No negative numbers will be generated from this particular read. So the negative number, only negative number that is going to be generated from this read function, or read function of this input file. Yes, it is actually reading the ASCII values and then writing those ASCII values in character format using this height. So generally it is reading byte. So what we say, if you are asked what is the type of this read, you say byte. And byte integer is greater than byte. The size of integer is greater than byte. That means this particular value is being converted into int again. So that is what is happening here. And -1 means we have reached the end of file. So when this inf.read reaches or returns -1, that defines that we have reached the end of file for that particular method. That means we don't have any content. So until and unless it reaches end of file, we are going to read something and we are going to write something. Okay, so this is what happening in this particular code. Now again, I am deleting this output folder, output file, and we have removed this particular code. We don't know what is happening in this particular code, and here it is written system.out.println complete. Okay, then we have closed all the files. So don't forget to close all the file objects. So let's just execute the code again. So just compile it like this, and now just again we want to execute it input.txt. Enter. Oh, sorry. I guess I forgot to save. So input.txt. So as you can see, copy from input file to output file has started and completed. So you cannot see that particular buffer, that or the progress bar. Okay, no problem. So again, if you see that we have found this output here. So my name is John. This is the file copy example. So as you can see, the copy is successful. So what was that? That particular progress bar was an illusion created by me using a particular feature of Java called thread. So using thread, we have created a progress bar to make a illusion that the copy is going on. So that is our progress bar. What I have done here, I want to print dot 10 times. So what I have done, I have written x is equal to 0, x less than 10, x plus plus. So from starting from 0 to 10 or 9, we are actually printing dot. So 10 dots will be printed there. And along with all the dots, we have this particular method. So let's remove this method first. So let's remove this method first and see what is happening. So yeah, we are just going to execute that. So as you can see, it has completed instantly. Okay, without any wait. What this does, so this is a method called sleep that is available from thread class. So it used to sleep this current thread for 50 microsecond, I guess. So 1000, 1 second is divided into 100,000. So that means if you mention here 1000, so this is 1 second, I guess. So 1 microsecond, I guess. So 500 microseconds are being stopped. So for that particular time period, it will stop. So half a second, there will be a pause for half a second. Yes, it will pause for half a second. You can just adjust the speed by this time. So 500 means half a second. So if you just make it 250, so it will 1/4 of a second. So it is much more faster now, right? If you make it 100, so 1/10 of a second. So this is much more faster. If you make it 1000, it will be 1 second delay. So we are adding a delay to the current thread. Current thread in the sense the main thread that is going on, that is executing. So it is 1 second delay. So 500 second means it is a half a second delay. So the next topic that we are going to learn is actually multi-threading. So that's why I have just shown a simple example of thread where we have just used a function that is available from the thread class to put this particular thread that is running, that is called main thread or thread 0 if you are talking about ID. So we are actually sleeping that thread 0 for that much time that we are specifying in this second. So this is an in nanoseconds or microsecond, I guess. So milliseconds, sorry. So this is milliseconds. That is 1 divided by 1000 seconds. So now let's move into the slides again. So have you understand this particular program, everyone? Okay, so it is 12:50, I guess. Okay, so let's just do one thing. Let's start from 2 p.m. again. Okay, because this is the end of first half where we have already learned file handling, and there is one question from file handling in your program, in your theory for MCA. There is a program as well as there is uh, uh, some problems related to file in your uh, questions in theoretical question, and in the next session that will start from 2 p.m. we are going to talk about multi-threading and what are the uses and how we can actually implement different threads or multiple threads in Java program. And there is one dedicated question from multi-threading as well in your exam.